Okay, lesson 5.2, rewriting percent expressions. Okay, so, and we're going to learn how you can rewrite expressions to help you solve markup and markdown problems. I'm going to tell you what those are all about coming up. Right here, a markup is one kind of percent increase. We just learned about percent increases. You can use a bar model to represent the retail price of an item. There are retail prices and there are wholesale prices. Retail price is what the customer pays. Wholesale price is what a business like Walmart might pay. They pay less for the item and they sell it to the customer at retail price for a markup for more money. Okay, so to make a profit, stores mark up the prices on items they sell. A store buys skateboards from a supplier for S dollars. We don't know what the amount is. We're just going to call it S for now. What is the retail price for skateboards that the manager buys for $35 and $56 after a 42% markup? So each of these items are increased by 42%. We're going to use a bar model for this. So draw the cost of the skateboard. So this is the skateboard right here. Skateboard, this full thing. And draw a bar that shows up the 42%. So this is 42%, not quite 50%. 50% is like about here. 42% is there. So this 42% gets added on to the total price of the skateboard. So the skateboard plus 42% of the price of the skateboard is the retail price. So these bars together represent the cost plus the markup. So our retail price, our original cost, S, plus the markup, 0.42S. Now S, when you have a variable, that's the same thing as saying one of those. So one of these plus 0.42. Now what you should see is 1 is the same thing as 1.00. The decimal point is always right there. We just don't always write it. And then 0.42, when you add decimals, you have to line up those decimals. And there you get 1.42. There's that right there. Times the price of the skateboard. Okay. Use the expression to find the retail price of each skateboard. Fine. We have the coefficient. That number is a coefficient, the number in front of the variable, or being multiplied by the variable, I should say. 1.42 times the cost of the $35 skateboard, which we're supposed to find right up here, is $49.70. So we should see that this is an increase of that, 42% increase actually. And 1.42 times $56 is $79.52. So this is the price that the store paid for the skateboard. This is the price that the customer walking into the store is going to pay, the retail price, wholesale, retail. And so I'll actually write this here. Wholesale. And this is retail. Okay, what if the markup changed to 34%? How does the expression for the retail price change? Well, instead of the 0.42, that would now be 0.34. Instead of 1.42, it would now be 1.34 times the price of the skateboard. Okay. Next, Rick buys remote control cars to resell. He applies a 10% markup. Make two expressions for this. Well, we can have the cost of the car, car. So the cost of the car plus 0.1 times the cost of the car, or 10%, because 10% is equal to 0.1. Now we can take the 1 plus 0.1 and call it 1.1C. And that's a little bit easier right there. If Rick buys a remote control car for $28, what is the selling price now? Well, it is going to be 1.1 times the cost of the car. So 1.1 times 28 is $30.80. Oh, and I wrote this. This is multiplication here. When there's no operation in between, that's assumed to be multiplication. An exclusive clothing boutique triples the price of the items it purchases for resale. And these boutiques are these little stores often that will sell stuff like this. So what's a boutique's markup percent? Well, it's 200%. I said at some point, yeah, where did I say it? Did I say it over here? I did. I said it in a previous lesson. If you have 100%, oh yeah, the previous lesson, 5.1, 5.1. If you have 100% increase, that is a double in the price. If it's a triple, that's going to be 200%, because you have your price, and then you have maybe your cost of your item C, 1C plus 2C. So write two expressions that represent the retail price of the clothes. We have the cost plus 200% of that cost. And 200%. 200% is equal to 2 times something, because percent means out of 100. So 200% divided by 100 is 2. So that's why 200% is equal to 2. Oh, you couldn't quite see that there. So the cost plus 200% of the cost, 300%. Or triple the cost right there. Okay, I hope I wasn't confusing about that. One of these plus double the size of it is triple the size. Okay, calculating markdowns. An example of a percent decrease is a discount or markdown. They both mean the same thing. A price after the markdown may be called the sale price. Often, items are put on sale if they're not selling soon enough. They will mark it down so it's more attractive to buy that item. You can also use a bar model to represent the price of an item. Okay, so our discount store marks down all of its holiday merchandise by 20% off the regular selling price. Find the discounted price of decorations that regularly sell for $16 and $23. So in our bar model, the P is the regular price that you would pay for that item. And 20%, here's 20% of the P. So of means multiply, so that's 0.2 times P. So that's 20% of the entire thing. So our expression to find out, we're removing this part here. This whole part gets removed. So what you're going to pay is this part, and that is the P minus this 0.2P. So the difference between the two bars is this. But we could be a little more efficient with this. So we could take that expression, P minus 0.2P, and P counts as 1P, as we saw prior. P is equal to 1P. And if I take that 1.00, and I subtract the 0.2P, oops, yeah, 0.2 is 0.20, I get 0.80, which is equal to 0.8. So 0.8P. And I actually see this as something else too. See, if you have 20% off of an item, let's say you have 20% off an item, and the entire price of the item, so if you don't pay 20%, what percent do you pay? You pay 80%. Hopefully that makes sense, because the 20% and the 80% make 100% of the cost of the item. So if it's 20% off, that means you don't pay the 20%, you pay the 80%. And here it is, 80%. So that could be a quick way to calculate that as well. So we take that 80% of the $16, because remember, we have to find the selling price, the discounted selling price of $16 item and $23 item. So 80% of 16, or 0.8 times 16 is $12.80. And 80% of $23 is $18.40. There you go. So we're going to conjecture. We're going to use this information and try to go further with it. Compare the single term expression for retail price after a markup from example 1 and a single term expression for a sale price after a markdown in example 2. What do you notice about the coefficients of the two expressions? Okay, so let's go back to, here is the example 2 coefficient. It's the number multiplied by the variable, 0.8 right there for the discount. And going back to example 1 here, here's the coefficient for the markup. What do you notice? The markup is greater than 1. And the markdown is less than 1, because if you multiplied by 1, it would not change the price at all. So a markup includes a coefficient greater than 1, and a markdown includes a coefficient that is smaller than 1. All right, so we have this here. Bicycle shop marks down each bicycle selling price by price. The price is B, and they mark it down by 24% for the holiday sale. Make a bar model. So this is B, 1B. It represents the bicycle selling price. And we are marking it, let's see, we're marking it down. So we're taking 24% of B. And this other part is the full B minus the 24%. So 1 minus 0.24 is 0.76. We end up paying 76% of the price of the bike, or 0.76 times B. And let's see, Jade sells pillows. For sale, she marks them down 5%. Okay, write two expressions that represent the sale price of the pillows. Well, we could take the price of the pillow, 1p, minus 5% of the price of the pillow. Or we can take 1 minus 0.05. 1 minus 0.05 is 0.95. Or it's like 100 minus 5 is 95. So 0.95 times the price of the pillow. If that pillow is $15, well, let's use our expression here. 0.95, right here, 0.95 times the price of the pillow is $14.25. And I believe that's all you got to know for this. Yes, it is. There you go.